the negative side of the oscilloscope, which is the black side of this BNC adapter, should be connected to the negative side of the interface of the source. Okay, both of these devices use the same power. For this reason, they share the same ground. If you have the ground of one connected to the positive of the other, you will have a short circuit and you will not have any signal. Okay, so here is the oscilloscope, and this one is capable of reading two signals at the same time. That's why we have channel 1 and channel 2. Now, for each of these channels, there are two main controls. The first one is the position, and the second one is the scale. The position allows you to shift your signal up and down because this is for the vertical, okay? And keep in mind that the oscilloscope is a representation of voltage versus time. The voltage being the vertical axis and the time is the horizontal axis. So anything that has to do with the vertical is actually going to be voltage. Anything that has to do with the horizontal, which is right here, this section, is going to be with the time, okay? So this is position knob, which allows you to shift your signal up and down. And this is the scale knob, which allows you to zoom in or out. Here I am zooming in to the signal and I'm zooming out. Notice that changing these settings does not change the actual signal. It only changes the scale of the graph. That's it, okay? So here we have similar controls for the horizontal axis, which is the time axis. So this is the horizontal position and this is the horizontal scale. Notice how I am zooming out and I am zooming in this case, okay? Now, before starting any reading, we have to remove any settings done by previous users, okay? For this reason, I'm going to press the default setup button right here. Now, this restores the oscilloscope to the default factory setting. And notice that you can undo this by pressing this button. Okay, here it says undo default setup. Now, by the way, these buttons are called soft buttons. The function of each one is displayed on the screen beside it. Okay, so now after I press the default setup, the menu changed and we have beside this one, it says undo default setup. So if I press it, I'll go back to the previous setup. Now, after you press the default setup, there is an important thing to do, which is to press on channel 1. Now, when you press the default setup, the oscilloscope assumes that you are going to use the probe that comes with it. But we are not going to use the probe. We are using the banana plug wires directly, okay? So if you look here, it says probe 10x voltage, which means that the oscilloscope assumes that the voltage that it is reading is attenuated 10 times or reduced 10 times. So it's going to give you a value multiplied by 10. So we have to change this first. Okay, so I'm going to press on this soft button on the probe 10x voltage. And then here it says attenuation 10x. I'm going to press on this one. Now, once I press on this one, I have a menu to select from. Notice that once we press here, this LED turns on, which means that this becomes active. Now, to make our selection, we can use this multi-purpose knob, okay, to change between settings. And then to select the setting, you press on the knob itself. So I want the 1x. So I have the 1x highlighted, and I'm going to press the same knob. Now the attenuation changed to 1x, okay? If you are using the two channels, you have to do the same setting for the other channel as well. So you press on channel 2 and you have to change it again. So let me redo it quickly. This one, and then attenuation. Then you select 1x and press. Okay, let's go back to channel 1. Now to hide the channel, notice that channel 2 appears now. To hide it, I will press on channel 2 twice. Okay, now I have only channel 1 displayed. Now notice that my signal is much larger than the screen. I can change this by adjusting the setting here, the scale setting. But also there is a nice button here which says auto set. I'm gonna press on this one. And it's going to set my signal automatically to the best view. So for the first reading, we need VRMS from the oscilloscope. Okay, look at the values displayed here, which appeared after I pressed the auto set. Let's look for the RMS. Here it says cycle RMS 854 millivolt. But notice that the reading is fluctuating. Okay, this is caused by noises coming from the environment. To avoid all of these issues, there is a nice function with this oscilloscope which says single here. Okay, when I press this, it will take a snapshot of your signal and just freeze it. Okay, now you can, after pressing this, you can turn off your power supply and the signal remains here. Let's go back to the first reading. So we got the RMS value of 854 millivolts. So you write this in your table. After this, we need the vertical scale, which is the volt per division scale. Now this number is displayed here beside the number 1. So it says 500 millivolts. So this is the number of volts per division. In other words, every vertical side of these squares, here is a square, the vertical side is equal to 500 millivolts, which is 0.5 volts. Okay. After this, we need the distance from peak to peak. So we need to find or measure the distance between the bottom and the top of the signal. Now, the best way to do this is to shift the signal until the bottom of the signal lines up with one of the lines. And of course, always before doing this, make sure that your signal is displayed on most of the screen for accuracy. Now I shifted my signal down so the bottom of the signal lines up with this line right here. Okay. Now I need to measure the vertical distance, and notice that we have fine readings here that can be made. So I'm going to shift my signal to make things more accurate. Shift it sideways to line up the top of the wave with this center line. Okay, and then measure the distance. So in this case, we have 1, 2, 3, 4, 5, about 5 centimeters. So you're now the first thing in the table of the time measurement is frequency reading from the oscilloscope. So let's see where this number is. If you look here, you'll see frequency 1.250 kilohertz. This is the frequency as measured by this device. So you just write down this number and of course convert it to the correct unit. In the lab manual, we need it in hertz. So 1.250 becomes 1250 hertz. Next, we need the horizontal scale in second per division. Now the horizontal scale is displayed here in white. It says M500 microsecond. Make sure that you pay attention to the unit always. So here it says 500 microsecond, which means that every horizontal side of these squares is equivalent to 500 microsecond time. Next, we need the number of full cycles. What we mean by this is the number of full cycles displayed on the screen. Now, before proceeding to this part, I want to shift my signal because now we're doing our measurement horizontally. Here is the horizontal controls. Shift it sideways. Now I have the top of the first signal lining up with the firstmost line on the screen. Now let's count how many full waves we have displayed on the screen. A full wave can be defined between the two peaks of the wave or between the two bottoms of the waves and so on. There are many definitions for that. So let's count how many full cycles we have. Here's the first one, second, third, fourth, and fifth. So I can see a total of 5 full cycles on my screen. So the number of full cycles is 5. The horizontal distance means the horizontal distance for these 5 cycles. Okay, so you have to measure how many centimeters or how many divisions you have covered by these 5 cycles. So in this case, we have to use this center line to get accurate readings. So I'm going to shift my signal down and then simply count how many divisions you have. So here in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, a total of 8 divisions. To use the cursor function, you have to press on cursor right here. And notice what we have on the menu here. It says source channel 1, and this is correct because we are using channel 1. And then for the type, it says off. So first we have to change this type. If you press on the type, now this one turns on, which means that we can select using the multi-purpose knob. And in this case, we are using the time cursors. So I'm going to switch to time. And right away we can see one vertical line shown here, which is one of the cursors. The other one is somewhere else, okay? We will look for it. But first, let's move this cursor to line it up with the peak of the wave. So I'm going to shift it. Now notice that cursor 1 is highlighted, and this is still on, which means that I can use this to shift or move my cursor left and right. So I'm gonna move it, and then I'm going to press here on cursor number 2. Now this allows me to use the same knob to move cursor number 2. So if I start moving, you can see that we can now see the second cursor. So I set cursor 1 on the beginning of the wave, cursor 2 at the end of the wave. Let's make sure that everything is accurate. And there you go. Now you can read the time difference between the two cursors from here. It says delta 820 microseconds. So this gives you the time difference between the two cursors. Press on cursors again because now I need to change to the voltage cursors. And then the source is correct. The type, instead of time, I need to change this to amplitude because the voltage is the vertical, which is the amplitude. So change to this one and press on the same knob. And now my cursors are horizontal. Now cursor 1 is highlighted and it is thick. The other one is thin. So I can move cursor number 1 to the top of the wave. Once I am satisfied with my location, I'm going to press on cursor number 2 and then use the same knob to move it, to line it up with the bottom of the wave. Because remember, in this part, we need to find the peak-to-peak voltage using the cursors, okay? Now, delta V between the two cursors is displayed here. Part we will go back to the time cursor because there is something you probably noticed in the time cursor. So let's change this to the type of time. Now the nice thing is that the time cursors will display for you at each cursor what is the value of the time as well as the value of the voltage. So I'm going to set my cursor number 1 at the location where I want my t equals 0 to be. So for example, if I want my t equals 0 to be at the top of the wave right here, I will set my first cursor at this point, okay? And then start moving my second cursor. So I will highlight my second cursor and move it, put it on top of cursor number 1. Right here. Notice that delta t between the two cursors is 0. So you will read the time values from here, which is the time difference between the two cursors. The voltage values in your table, you will take them at cursor number 2, okay? So now T equals 0 and V is equal to 1.2 volts. So this is your first reading. Next, I'm going to move cursor number 2 to the next position. You can take every one division or so. So for example, at this point, T is equal to 24 microsecond, and the voltage is equal to 1.2 volts. Okay, let's move it to the next point. For example, let's take this point. T is equal to 12.4 microsecond or actually 124 microsecond, and V is equal to 740 millivolts, which is 0.74 volts. So you keep repeating this over and over until you get the required number of points. Now you can use these values to plot V versus T for this signal on your computer, for example, or do any other processing on this data. Note that we have the two probes connected in the oscilloscope, so you want to make sure that the setting on the probe is the same as the setting on the oscilloscope. So if I press on channel 1, it says probe 1x voltage, and the probe connected to channel 1 is set to 1x. We'll do the same thing for both channels. So if I press on channel 2, here it says channel 2 and probe 1x, and the probe itself is set to 1x as well. Now we will show you how to use the XY function. The XY function takes one of the channels, plot it on the x-axis, and the other channel on the y-axis. And this can be very useful in some of our experiments. So to use the XY format, you press on Utility button, and then you press on Display, and then here it says Format YT. Instead of Format YT, we need the format to be XY. Okay, so again, this turns on, so I can use the knob to select and then press to make your selection. Now it's going to plot one of the axes or one of the channels on the x-axis and the other one on the y-axis.